In this line of work, nothing can be left to chance. That's why experts go with the new industry leader, DWL Nonel Super Detonators. The Dyno Nonel tradition of excellence began more than 125 years ago with Alfred Nobel's invention of the blasting cap. Without Nobel's blasting caps, nitroglycerin would have been unusable, and the discovery of dynamite may have been delayed for years. Just as Nobel's invention of 1867 changed explosives history, the Nonel Super Detonator represents the culmination of years of research and a new level of technical excellence. The DWL Nonel Super offers blasters significant technical benefits previously unavailable. The Nonel Super is a high-strength detonator. A total charge weight of 1 gram makes the Nonel Super Detonator the strongest in the industry. This fundamental benefit starts where your blast begins, the initiation. The 1 gram charge enables the Nonel Super to initiate the most insensitive of today's cap-sensitive emulsion and water gel explosives. As an example of the Nonel Super's high strength and reliable performance, it was subjected to sub-zero conditions, where the sensitivity to initiation of explosives is most critical. Below 0 degrees centigrade, temperature can cause initiation problems with cap-sensitive water gels and emulsions. At -8 degrees centigrade, the high-strength cap initiates cartridged emulsion, which reaches steady-state velocity within 60 millimeters from the detonator. This results in more energy where it's needed, at the bottom of the borehole. At -8 degrees centigrade, a number 8 strength cap initiates the cartridged emulsion, which then requires 115 millimeters from the detonator to reach steady-state velocity. The result is 10% less shock energy at the bottom of the hole. In this test, we cooled a cap-sensitive emulsion to -36 degrees centigrade. The witness plates clearly show the Nonel Super detonates at full strength, even in extreme cold. Now watch what happens when our competitor's number 8 cap is detonated in the same cold conditions. There's no comparison. The Nonel Super is reliable even in areas where the temperature may go as low as -40 degrees centigrade. Low temperature will also simulate insensitive explosives that can result from excessive storage, temperature cycling, or poor quality control at the manufacturing plant. The acrylic block test is another measurement of energy output from a detonator. This test clearly shows the Nonel Super to be the strongest in the industry. The trend today and in the future is for commercial explosives to become less sensitive for safety reasons, but still function in small diameter applications. That's why Dyno standardized on the strongest detonator allowable. Most detonators meet general industry timing parameters. All manufacturers can make precise detonators. But Nonel Super gives you accuracy and precision every time. Our super accurate delay technology, developed for the electric Super, gives the Nonel Super the best timing accuracy in the industry. The Nonel Super design gives an allowable deviation of 6.5 milliseconds. That is independent of the cap interval. The industry allows a deviation of 12.5 milliseconds as an industry standard. This prevents overlap in a standard millisecond series with 25 millisecond intervals. In this demonstration, we measured the accuracy of the Nonel Super at 17 milliseconds. Filmed at 500 frames per second, each frame is equal to 2 milliseconds. This test clearly shows that the 17 millisecond delay fires within the 4 millisecond deviation standard for this delay. This group fired at between 15 and 17 milliseconds, or within one frame of the filmed explosion sequence. At 25 milliseconds, the total deviation allowable is 4 milliseconds. Our test demonstrated a 4 millisecond scatter. This group of fixed delays fired from between 23 and 27 milliseconds, or within 2 film frames. Finally, test results with a 109 millisecond delay allow a total deviation of 12.5 milliseconds. On this test, we measured 8 milliseconds of scatter. This group fired from between 102 to 110 milliseconds, or within 4 filmed frames. Testing proves that cap scatter is independent of cap interval and does not increase with the delay period, nor does the Nonel Super timing change with age. For the first time, it's possible to use a long delay time downhole and still have an allowable deviation of 6.5 milliseconds. The explosives engineer adjusts blast design parameters to achieve desired results. Parameters of spacing and burden, explosive properties, total energy and timing sequences are all extremely important. But timing control is crucial for good results. Accurate and precise timing results in vibration control and good fragmentation. Pre-split and wall control techniques demand controlled timing. New techniques such as tensor vibration control and frequency shifting also demand timing that is precise and accurate. Explosives engineers require a precision initiation system that meets today's government regulations, environmental concerns, and economic challenges. The Nonel Super meets and exceeds those demands. In this computer simulation, we're looking at a typical blast using Nonel Super 500 millisecond caps in the hole and 17 and 25 millisecond snap lines on the surface. We can demonstrate a probability of success based on scatter factors of 1% and 5% in this simulation. With a 1% scatter factor, the probability of success is 100%. All holes fire in proper sequence, indicated by a green color. However, in this simulation, with a 5% scatter factor, the red color indicates an out-of-sequence firing pattern. There's less than 50% a probability of success. Using Nonel Super 500 millisecond caps will minimize your inventory, economically improve vibration control, and increase fragmentation. The Nonel Super detonator features a super shock tube with an exclusive 3-layer design. This co-extruded 3-layer design has an inner layer which holds the explosive mixture in place for dependable initiation of the detonator, a middle layer for strength, and an outer layer for abrasion, oil, and water protection. The result is an economical detonator that can withstand the demands of today's blasting environment. Material properties are designed to give this detonator superior strength, abrasion resistance, and improved handling and deployment. Close spacing and water-saturated ground conditions can result in water hammer. This dynamic shock desensitization of detonators and explosives is common in the blasting industry. In this situation, the shock wave from an adjacent hole has time to travel the distance to the next explosive or detonator. Bypassing the delay interval, it sympathetically detonates the explosive. We conducted a test using a 50-gram pentalite booster as a donor charge and spaced both Nonel Super and competitor detonators at 75, 150, 225, 270 and 300 millimeters from the donor charge. The detonators were offset so that the water hammer results would be determined by the booster charge, not the other detonators going off. The results clearly show the Nonel Super is much more resistant to the water hammer. The Nonel Super fired sympathetically at the 75 millimeter mark, but were ineffective at greater distances. When recovered and test fired, they reacted normally. The competitors' caps, however, fired sympathetically out to 225 millimeters and showed damage out to 300 millimeters. Often a shock wave doesn't have enough energy to initiate the detonator, but water hammer can damage the unit so that it doesn't fire or fires erratically. If errors like these had happened on the job site, it could have cost thousands of dollars. Unlike any other detonator, the Nonel Super's delay and primer charge are encased in a steel sleeve. This exclusive steel sleeve design protects the sensitive areas of the detonator and makes it very resistant to water hammer. In blasting applications using close spacing and burden, and in saturated ground, the Nonel Super can mean the difference between success and failure. One of the most important features of the Nonel Super's design is its improvements in safety. Industry tests show Nonel caps can withstand 4.5 kilograms dropped from a height of 250 millimeters without detonating, but dyno demands better. When the distance is more than doubled to 610 millimeters, a 4.5 kilogram drop barely dents the Nonel Super, and the cap still fires normally. Without Nonel Super's exclusive steel sleeve, the competition can't hold up. In test after test, the lead fuse element is crushed. Any detonator in this condition is unreliable and unusable. The steel sleeve protects the most sensitive part of the detonator, and this, along with the use of diazo as a primer charge, makes this detonator much less sensitive than the old design. The Nonel Super also features a transition element whose function is to seal the detonator. This helps give the Nonel Super its unmatched accuracy, preventing suck-out failures and modulating incoming energy, which also aids in accuracy. The air gap test also shows how the steel sleeve protects the primer charge from initiation. The Nonel Super fired at a standoff of 75 millimeters, but did not fire at further distances. The competitor's unprotected primer charge and fuse element fired at a standoff of 200 millimeters and closer. Placing the most sensitive parts of the detonator in a steel sleeve increases the Nonel Super's resistance to impact and rough handling initiations. And the Nonel Super's isolation cup has the traditional advantage of being resistant to electrostatic energy. As with all explosive devices, the Nonel Super contains primary explosives and must be carefully transported, handled, stored, and used. But the Nonel Super design offers a new standard for safety in non-electric initiation systems. Years of research and development have produced the Nonel Super Detonator. The detonator with high strength, high accuracy and precision, super shock tube, water hammer resistance, and safety improvements. The Nonel Super from DWL, the best detonator in the business.